everybody, this is Miss Peachy. I totally forgot to put my headset on here. From your WCA Earth Science class. And we are doing a video tutorial today to go through a portfolio on star composition. This is the one you need to complete coming up here. So I'm going to go ahead and click on this. And this brings us to the lesson viewer. Unit 5, Lesson 17, Star Composition. And when we click on it, it opens up that Vega viewer you guys are so familiar with. And you can kind of see here that throughout the slides, you will kind of get a look at all the different components of this lab activity. Let me just remind you that you're going to want to go to my website. Here's my website here. I just clicked on my link to it. And go up to the Earth Science B tab at the top of the screen. Scroll down. And as we get down to the bottom of the screen, there's a worksheet that says Spectroscopy Lab Worksheet. So please use this. Don't use the PDF in the lesson. If you use the PDF in the lesson, sometimes what happens is your information won't save properly. And you end up having to redo the lab, and nobody wants to redo it, do we? So don't use the PDF. Instead, use this. When you do this, you're going to pop it out. It's going to show up as Google Doc. And you can download this. And it opens up in Microsoft Word, which is fantastic. So let me bring that all over here for you, and you can kind of look at this one. Okay? So I want you to notice as you scroll down here, you are going to be doing part 1. And through the analysis of part 1, you will not do part 2. Do you see what this says here? The stellar spectra lab activity requires revision. You may leave the remainder of this worksheet blank. So this is telling you that you do not need to do part 2 of this. It doesn't work. Okay? So we're just doing part 1. So let's go back to that Vega viewer. Actually, I'm going to go back to, where is it? Here it is. There we go. And when we go to the bottom, you're going to note it says lab activity. I'm going to click on that. And this is giving you some background information, which we're going to go through real quick. So it talks about the fact that every time you look at an element that's heated, it gives us a signature light pattern if viewed through a device called a spectroscope. And that light pattern is different lines of color that are at different wavelengths. So each one of the scale here corresponds to wavelengths in nanometers. So simpler elements like lithium here have a fairly simple pattern, just 2 colored bars. Heavier elements like barium have more complex pattern. And that pattern is unique to that particular element. So it's kind of analogous to your fingerprints or your DNA, which is unique to you. If I am able to see stellar objects like stars from distant parts of the galaxy or clouds of gas and dust in the outer regions of space, I can actually use a method called spectroscopy to analyze the light that comes from these distant objects to be able to determine what materials compose those objects just by looking at their stellar spectrum. So let's go to the lab activity. And we're going to go down here to where it says, actually, let's see where I'm at here. 1 second, guys. Okay. Yep. Okay. Okay, just want to make sure I had the right thing. So we're not going to click ahead to where it says lab activity down here. Not going to do that part. We're actually going to scroll down where we have the emission spectra lab activity. That's the one that we want to do. The other one's the one that's at part B that's going to be canceled. Okay. Remember, don't click on where it says Spectroscopy Tool Lab Report Worksheet. That's the one that's on my website. Alright, so we'll click on this one. It talks about, again, every fingerprint is unique, as are all the nose prints for dogs. I don't think I knew this, actually. And so, too, are the spectral lines for each element on the periodic table. Okay, so we're going to look at some of these emission spectra today. So, I'm going to click on Learn More, and then you're going to be getting a whole series of different elements: hydrogen, helium, carbon, oxygen, and so on. Okay. When I look at my worksheet here, part 1 that we're going to do, you have a data table, and I just did hydrogen for us already. So you're going to type in the element symbol, which for hydrogen is H. Let's go back to here. I'm going to select hydrogen and then click View Data. The element symbol is H, and then it asks us for the atomic number, the lowest wavelength in spectrum, the highest wavelength in spectrum, and the total number of spectral lines. And that's actually pretty easy data to attain. You can get it right from this data table. Symbol, lowest number is 410 for hydrogen, highest number is 656, and there are 4 spectral lines, and you can actually view those right here. Okay? Make sense? Just basically copying that information down. You're going to do that for every element on there. When you're done with this, you have to go back to the top of your lab because you have a mystery you need to solve. The mystery is that you have a gas that a company has a leak, and they're trying to figure out what gas this actually is, because they have different methods to deal with different types of gases. It says the company uses a variety of gases such as hydrogen, helium, argon, neon, xenon, krypton, and even mercury vapor in their bulbs. This is the gas that's leaking. So you need to see which spectrum this most closely matches. So as you're going through each one of these, okay, I want you to make sure that you look at the pattern here and you compare it to the pattern here. It would be good to get these side by side if you could, to compare them. If you just, one thing you can do on your computer, you can click and drag your box kind of over to the, like one of your windows over to the left all the way, and you can split your screen, and you can kind of compare these guys side by side. So that's kind of a cool trick. Because after you write down your data on here, I want to make sure that you compare the two pictures to see if they match. This one doesn't look like a match. I don't see that bright yellow line there, and I definitely don't see all these little dimmer lines as well. So I would go back to here, and I would say, initially that maybe make some mark here that this is not a match, right? I don't know how you guys want to do that. I might just color this box like red, just because that to me means nope, no match. And then as you go down, when you find the match, maybe color it green just to kind of indicate it's the match. Okay. Once you've got all that data collected and you've checked, you're going to identify your leaky gas. And then you're going to explain how you knew that that was the correct gas. And then finally, you're going to answer questions 5, 6, and 7. Question 5 says, in the emission spectra tool, a table shows ranges for wavelength frequency and photon energy for different colors of light. What color of light is associated with the highest energy? So which colors? You basically have the whole color spectrum, red, orange, yellow, green, blue, and violet. Which color is associated with the highest energy? And how does this relate to the flame color on a stove? So think about a gas stove. What color is the flame when you have the heat turned on high? If you've never used a gas stove before, think about a propane gas grill or maybe a Bunsen burner. So if you've used one of those things, you can think about it too. If you've never used any of those, just think about a flame from a fire, a campfire. Like where and what color is the hottest part of the fire? Question 6. Use your data, compare atomic number with total number of spectral lines. Is there a pattern? Do you find that the number of spectral lines is kind of related to the atomic number? If the atomic number is low, do you have lots of spectral lines or just a few? If the atomic number is high, do you have just a few spectral lines or do you have a lot of them? Explain the presence or absence of a pattern based on what you know about atoms, electrons, and emission spectra. Question 7. Use your data, compare atomic number with lowest and highest wavelengths in the spectrum. Okay, so again, you're looking at this number. You have 410 and 656. Do you see the numbers here? Are they somehow related to the atomic number? So for example, if the atomic number is low, is the wavelength of the lowest one really small or is it really high? Is there some sort of a pattern there? That's it, ladies and gents. Remember, you don't have to do part B, you only have to do part A. So if you have any questions or concerns, feel free to give me a webmail message. At this time, you can't call me because we will be working from home for the next few weeks. So just make sure you give me a webmail message and I will call you back. Have a great day, everybody.